So welcome everyone to this second episode of YMP Lunch and Learn webinar series. So last time we had our first episode on tailing reprocessing, and this time we will have our second episode on the refractory raw material market. And to present today, we have Alexandre Ordoche. So Alex works in the strategy and development team at RHI Magnesite, which is a global leader in refractories. Previously, he was also working as a community analyst at CRU, and he holds a Master in Science from the Imperial College in London and from Mount University in Austria. Maybe just before I let Alex present himself, just a bit of housekeeping. So please keep yourself in mute during the presentation. If you have any questions, we will have a 15 to 20 minutes discussion time at the end of the presentation, and you can already start putting your question in the chat in preparation for this moment. So yeah, with no further ado, Alex, thanks again for being with us today. Very appreciate your time, and yeah, the floor is yours.
Thank you very much. Thank you very much to you, Jean, and YMP Switzerland, and to you, Tristan, to giving me this opportunity to talk about this kind of niche raw material market that hardly ever anybody has ever heard of. Even if you are a specialist working in the metals industry, most people do not see this market, which pretty much flies below most radars, despite being a global market with a value of about 30 billion euros. And we will see that we all use or indirectly consume those raw materials, and we are really dependent on them without actually knowing it. So first, I want to explain briefly to you what refractories are. Then I want to introduce the company that I work for, RHI Magnesita. And then we will talk a bit about the market structure of the refractories and the market dynamics of the refractory raw materials. And I will point out one deep dive into the alumina and bauxite refractory market, which maybe some of you can relate a bit more than some other of the very niche bits that we will consider in the next few minutes. And I want to conclude with the strategic implications for vertical integration of the refractory producer. And this then will suddenly allow us to say why certain raw materials are traded internationally and also how they are traded internationally. So let's start with what are refractories. So refractories are mineral-based products that have a very high melting temperature. And they are used in absolutely every application that involves higher temperatures than 800 degrees. So this starts with any furnace that you see, even a Swedish oven that you may have in your house has some refractories inside. But we at RHI Magnesita consider normally a refractory to be only a high temperature, so what we call refractory, if it sustains temperatures above around 1200 degrees. Everything below is more like a lower grade part of the market. Basically, all metal production involves consumption of refractories. In the slide, you see four metals and cement or concrete, which with all uses refractory products with varying specific consumptions and varying temperature resistance. If you want to produce 1 ton of steel, for example, you need around 10 to 15 kilograms of refractories with a heat resistance up to 1760 degrees. So that's like on the low, on the higher range of the temperature range for refractories. If you go to the very high level, very high grade refractories, then you can manage temperatures above, just above 2000 degrees. So don't mix up a refractory with, for example, a special ceramics. So if we talk about some nitrogen compounds with metals or so, these are not refractories, those are ceramics. So think refractories as really a mass-produced product out of a mineral raw material. And about these raw materials, I want to talk later. But before, let me introduce briefly to you the company that I work for. So RHI Magnesita is the largest refractory producer in the world. we have a revenue of about 3 billion euros. It varies a bit with the raw material prices and with market dynamics. We have a global footprint, as you see on the map. We have about 15% global market share, and we are by far the largest. The second largest producer has about 10% market share, and we are headquartered in Vienna, and we are listed at the London Stock Exchange, and so we are in the FTSE 100 index in London as well. We have production facilities around the world, with the main ones being in Austria and Germany and in Brazil. So RHI Magnesita merged in 2017 out of RHI, which was based in Austria, and Magnesita, which was based in Brazil and South America in general. So you see that we do make about 30% of the revenue in Europe, CIS Turkey, about 18% or so in North America, 22% in South America, and then we have a growing presence in the emerging markets in Asia, most noticeably India, China, and Vietnam. On the right-hand side, you see some of our competitors and companies you may have heard, most likely not, but I think maybe you've heard about Saint-Gobain or Imerys. Those guys, so Saint-Gobain has a division for refractory, and Imerys is a key refractory raw material supplier for certain products that we will touch on in the next few minutes. In total, RHI Magnesita shipped about 2.3 to 2.5 million tons of refractory. So this is the order of magnitude that we talk to, few million tons to several hundreds of kilotons. And in total, we mined 1.2 million tons of refractory raw materials, magnesite and dolomite being here by far the biggest ones. And what that means, we will talk about it in a few minutes. So I want to slice and dice now the refractory market a little bit to give you an overview of what groups we have in this very diverse market. So the issue with refractories is that it is, compared to other metals like copper, nickel, iron or so, a quite small market. But even within this market of about 26 billion euros, that what we consider at RHI Magnesita, the refractory market, we have a very, very, very large diversity of products and raw materials that are needed. So we talk about the refractory market being about 24 million tons globally. Out of those 24 million tons, about half is our basic raw materials. I will explain in a sec what that means. Then about 40% or so are non-basic non-basic refractories, and the remaining are recycled refractories. And this recycling element will become more and more important in the future. This you can compare, for example, to the rise of steel scrap recycling in the steel industry with the arc furnace push in a lot of regions, particularly US and China. So the group of the basic refractories comprise about 15 million tons. 15 million tons, and they're split in 3 different product classes and raw material classes. So first you have 80% magnesite. So magnesite is magnesium carbonate. Then you have 12% of dolomite, so calcium magnesium carbonate. And then you have 9% of others, which is, for example, fused magnesia. I will mention this in the next slide. So it's rather simple, right? So 50% of the market is covered by 3 raw materials that you can pretty understand in a pretty straightforward way. The problem comes with the non-basic refractories. So these about 9 million tons of a global market are split into a very large number of different raw materials. And I just show here, let me turn on the pointer. In this chart, I'm just showing the top 5 non-basic raw materials. So we talk about alumisilicates like sillimanite, andalusite, and so on. Then also fire clay, then alumina, which we'll take a look at a bit more detail later, and then also silica, so basically quartz, and then also others. And just these others, for example, comprise another 10 to 15 different raw materials. overall, we see from a market dynamics that the non-basic refractory market grows a bit faster with about 1.2% CAGR. And this is driven by what we see in the right-hand side of this slide by our end-use industries. So by far the biggest consumer of high-temperature refractories is the steel industry. You see, out of those 24 million tons, almost 20 million tons are consumed in steel making. Yeah, there is about nearly 2 billion tons of steel produced in the world. And if all of that consumes about 10 kilograms of refractories, yeah, you can do the math. That fits approximately. Then the second biggest consumer is the cement and lime industry. So basically cement production that you use for concrete. Then comes also non-ferrous, which is particularly a consumer of very high quality products that we produce very prominently. And also glass, aluminum, and EEC comprises a set of all industrial furnaces like power plants, waste incineration, oil and gas, carbon black. There are more applications. There are about 50 different applications that we cover. So overall, when you take a look at this, you basically find all metals within our consuming industries. And you will also see that most of these consuming industries are somehow connected to the construction industry. So this is therefore a very key consideration for us, for a macro and strategic point of view, the construction industry growth. And this translates one-to-one to the demand growth. So we basically are in a low to no growth industry, because now China slows down a bit. In developed markets, we have basically no growth, and therefore value to bring value to our shareholders and so on, M&A and value optimization is the key point here, and not very aggressive growth in very diverse markets. A very interesting point for refractories in general is that it is a very small component of the overall cost of goods sold of our end-use industries, but they are highly critical for the practical considerations of the plant. So that actually the process really works. When we look at steel, about 3% of the total cost of producing steel goes to refractories. But if there is a failure in a refractory lining, for example, in a converter, then you have to shut down the plant. And therefore, technical reliability is really key for the refractories in general. Now we know how the refractories, so the end-use products, are sliced and diced. Now we go a bit more into detail in the raw materials, which you are mostly most interested in. So not surprising, we also split the refractory raw materials in a non-basic and a basic part, which is shown in this pie chart. And overall, we have a very high number of different refractory raw materials. So let's start with the easy one, which are the basic raw materials. I told you before, there is a magnesite base, so that burnt magnesia. Then there is fused magnesia, and then there is dolomite. That's basically it. For all non-basic, we have about 30 different raw materials that are used, and by far the biggest chunk are refractory clays. However, these refractory clays are mostly used in low temperature applications, and therefore they're not for us, it's RHIM, considered refractory raw materials for the markets that we serve. We mostly procure and process alumina and bauxite-based raw materials, and also special ones like chromite, olivine, and graphite. And in the next, in 2 slides, I will show you a little bit of detail on one of the value chains of the alumina-based raw materials that we see here on the top left of the chart, which are about 20% of the total market. When you have a refractory raw material, you need to have quite a complex supply chain and processing facilities to produce refractory, which may look and sound like a simple product, but I can tell you it isn't. So the first step for every raw material is a processing step. And this processing step is normally quite CO2 intensive, because the processing steps normally include calcining of the material, so basically heat treatment. For example, you take the magnesite, so magnesium carbonate, and you put it into a rotary kiln to basically get rid of the CO2 to arrive at MgO, so periclase. And this periclase, this mineral, has a very high melting point of about 2200 degrees. And this then is the foundation for the refractory properties of the magnesite-based products that we sell very prominently. And a similar approach also applies to a lot of non-basic refractories, your refractory raw materials. You have to burn, for example, fire clay to chamotte. You have to burn, you have to calcine bauxite. You have to, increase the grain size and all of that. Once you process your raw material, you can crush it, you can grind it and so on, and you can mix it with a certain recipe. And with this recipe, you basically adjust the physical characteristics of your product. And then you have three options what to do. Either you sell this so-called mix, so just this fine powder in a big bag, that basically looks like a concrete, like a cement. So if you remember with those cement bags that you can buy to make concrete at your house, it basically looks the same. It's a white powder. But you can also use the mix to already cast so-called precast shapes, or you can use this powder to press a brick. And there are huge presses with several hundred of tons of pressing power, and they press a certain shape of bricks. And later I will pick up a few examples that we have here in the office to show you, to give you an impression how the final product looks like. However, once you press the brick, you still need to give it their final properties. And this is done in a tunnel kiln and a temporal kiln. So you have to fire it again, which is again a CO2 intensive process. And then you do final processing like cutting, grinding, and drilling and so on. And only then you arrive at the final product. The dynamics, the pricing dynamics of these final products are basically governed by larger forces than supply and demand. Particularly when you look at the refractory raw materials. Let me make this small so that you can see anything, all of the slides. So the refractory raw material prices are not really governed by a demand and supply balance, what you normally read in a textbook, for example, those beautiful lines, and then you have an equilibrium and so on. Basically, it only matters what the Chinese domestic policies are doing, because as you are most likely aware, nowadays, China produces the lion's share of almost anything. When we look at steel, they produce 45%. In cement, they produce more than 50%. And with refractory raw materials, it is exactly the same. So we see here at the bottom of the slide, 4 different raw materials. And let's start with the magnesite, so the dead burned magnesite production. About 70% of the global production is in China. Although only 50%, well, only 50% of the global consumption is in China. So therefore you see large scale exports of magnesite-based refractory raw materials to the world. Even worse, from our perspective, it is for fused magnesia. That's a downstream product, a downstream magnesia-based product. There you have about 85% of the global production is in China. So when they decide to, for example, constrain the export of this raw material, the global industry has a really huge problem because there is no slack in the system. Something very similar applies to refractory grade bauxite as well. About 95% of the global supply either comes from China or is in the hand of a Chinese company. And this we will discuss in the next slide a bit more. One of the few exemptions of this is actually andalusite. So that's, andalusite is such a niche raw material with about an annual global consumption in the refractory industry of about 300,000 tons. But even this market is highly concentrated because you have Imerys that takes about 70% of the global market. In the price chart that you see in the top right of the slide, we can see what happens if the Chinese government cracks down on certain industries. So I lined up here 3 prices of key refractory materials. So DBM, dead burned magnesia, so basically magnesite, magnesite, then fused magnesia, the downstream product, and then BFA, which is brown fused alumina, so a downstream product of refractory grade bauxite. And you see that prices went down consistently since 2011 because the global industry is structurally oversupplied, and therefore, there is just too much there. Also, between 2015 and 17, there was a weak period in the steel industry and in the steel market in general. Therefore, prices go down. But then, mid of 2017, the Chinese government started its first crackdown, its first environmental crackdown in the heavy industry. And the refractory industry was basically like a collateral of that whole push, because the steel, cement, and metal and power producing industry was the main target. But because the refractory industry is also CO2 intensive, and if you don't do it properly, can be a bit dirty as well, it was a collateral, and that led to an extremely sharp rise in prices. So you see here DBM, that's the main one, it went up from, let's say, 350 beginning of 2017 to 1,200 euros a ton. So this is, sorry, US dollar a ton. That's FOB China, basically. So an enormous increase in prices accompanied with a contraction in supply. The same happened also to BFA, but to a lesser degree, because a lot of BFA production, as I will show on the next slide, is centered outside of China, and even refractory grade bauxite, not exclusively coming from China. And then after, around 2019, steel markets weakened a little bit, and the whole refractory industry adjusted to the new environmental restrictions and kind of the level that the Chinese government wants to see. And therefore, prices went down to basically the long-term trend, right? So prices retreated completely to about $300 a ton FOB during the coronavirus crisis last year. And only in December and late November 2020, they picked up again. And that's exactly also the point when steel prices started to increase. I think also copper prices, and basically generally the whole commodity market went up a lot. And this also drove the refractory raw materials, because suddenly all the metal producers want to maximize production because they see all of those very attractive prices, and therefore they buy refractories, and this feeds through, basically upstream to the refractory raw material producers in China. So let's go a bit into detail how the aluminum-based raw material value chain looks like. This is actually only about 10–15% of the global market, but I thought it is valuable for you because the basic raw materials are quite abstract, and I think with aluminium and bauxite it is kind of easier to get a connection for most of you, and therefore I chose this as an example of a quite complicated supply chain, which is not exclusively set up for the refractory industry, but it serves a very wide range of different industries. And so let's take a look. So first we have, let's say, the raw bauxite, right? And then we can discriminate between the non-metallurgical bauxite, so the very high quality bauxite with low iron, for example, and low silica and other impurities. And this is on the top. This is shown on top, but let's call it bauxite route. And then there's a second one, which is more like conventional, right? You go with a metallurgical grade bauxite, you do the bio process, and only then the supply chain really relevant for the refractory industry starts. So let's start with the bauxite chain. We see in the colors where the raw material comes from and where it is processed at the different steps. So first, about 75% or so of the non-metallurgical bauxite comes directly from China. But there's also one major deposit in Guyana run by First Bauxite LLC that provides vital non-Chinese supply. However, this company is also in Chinese hands, more or less. So eventually it is, again, highly concentrated. There are also some other very small producers in the world. But overall, the whole refractory grade bauxite supply comes from 4 companies, and almost all of them are Chinese controlled. Then you don't need refining, right? Because it's already high quality, but still you need to calcine it to get rid of the water and to do stuff with the grain cells and so on. And this is also what mining companies do in a lot of cases. However, then the kind of the break starts, because then you take the calcined bauxite and you can supply a very wide range of different end-use industries with the final product, which is called brown fused alumina. And therefore, there is a comparably large number of non-vertically integrated players that take the calcined bauxite and the non-metallurgical bauxite from the miners and then process them in a fusing process to the specifications of their respective end-use industries. And here, for example, the most noticeable names are, I think, Imerys, right, and also Rusal. So they do BFA. This is the red line, the price chart that I showed you in the last slide, and they only produce the qualities they need for certain industries. And that's a very small volume that goes into refractory industries when we compare it to the big total of brown fused alumina production. So let's go to the alumina pathway, and we see that the kind of supply chain is much more diversified, because the market for metallurgical grade bauxite and then also alumina is much, it's just much bigger. It is more distributed around the world, and there are just more players. And also Rio Tinto is producing bauxite and a lot of other major miners. But then, as with the bauxite route, there is a break when specialty companies come in to serve their respective end-use industries. And this is, in this case, already at the calcined alumina. So this is when you take the alumina and you calcine it to get exactly the properties that the end-use industries want. And the most well-known actually is Almatis that is doing that. And we, for example, are Magnesita buy calcined alumina for our finished products. However, calcined alumina very often doesn't do the job because it doesn't have the right physical properties. And therefore, you can even process it then further into white fused alumina and tabular alumina. And for those, you have again several companies that only do this process, which are not backward integrated and serve only their respective end-use industries. Here, for example, Imerys is again a major player in the white fused and the tabular alumina market. So again, the total bauxite supply is huge compared to what the refractory industry consumes. But within this consumption of the refractory industry, the variety of alumina and bauxite-based products is very large. And this, I think, now gives you already an impression of why it makes sense, why it doesn't make sense for a refractory producer to be vertically integrated into bauxite mining, because the value chain is much too complicated and the volumes needed are much too small to justify this enormous investment. In the chart here, I list again the major refractory raw materials, and those are what 2, 4, 6, 8, 10, 12, 13 different raw materials with their global demand in red, in kilotons, and their indicative price in dollars per ton FOB, and that's about 2019. And I think we just have to compare orders of magnitude here. So when we take at the alumina raw materials, so only the global demand, then we see that the demand is around 1 million tons. So between, let's say, 300,000 and 1.3 million tons. So this is the order of magnitude. For the specialty raw materials, it's even smaller. So we have about 300 or 100,000 tons. And obviously you would not start a chromite mine if the global demand for chromite for refractory is 100,000 tons, right? This is just a byproduct in reality. But if we go a bit lower this chart, we see that the big guys come in actually. So we see Chamot, so that's the processed fire clay. Global demand, 16 million tons. So about 3, 4, 5 times as much as the total other raw materials combined. And then also in the bottom, all the basic raw materials. So about 9 million tons of dead burnt magnesia, 2 million tons of fused magnesia, and about 1 million tons of dead burnt dolomite. And this now immediately tells you that most, the kind of the low-hanging fruit in terms of vertical integration is the other raw materials that you need in high quantity and have a comparably high price. If you compare, for example, the dead burnt magnesia price of, let's say, 760 with the non-basic raw materials, you see that the 760 is actually quite in the high range of the whole price series. For fused magnesia, it's even more, with more than $800 a ton common prices. And therefore, vertical integration is actually only attractive to refractory producers in the basic area. There are some exemptions to this. The most noticeable one is actually Schammelt and fire clay. Because of the very low price of, let's say, between $200 and $300 a ton, the freight value is very high, right? And therefore, the kind of the circle, which you can ship profitably, this raw material is comparably low. And therefore, there are a lot of refractory producers that have their small fire clay mine with 1-2 diggers in their backyard and have basically a captive mine next to the plant. And therefore, as I said, in particularly India, China, and also Russia, a lot of smaller refractory producers are vertically integrated. Even in Germany, there are actually some. While all the other ones, so the alumina raw materials and the other, so the specialties, are procured on the international market because you need specialized companies that know what they're doing and they know how to produce this very specific raw material at scale with a reasonable price. And this is now also what RHI Magnesita is doing. So we are vertically integrated in dead burnt dolomite. So in magnesite, basically, we have 2.5 mines in Austria. So Breitenau is the biggest one, you may know it. And we have several large-scale open pits in Brazil. And yeah, that's it. Yeah, that's it. That's it. And we also are vertically integrated in dolomite. So we have one large mine in China, and we have now a new underground mine in Hochfilzen in Austria that produces very high quality dolomite. And just for the experts among us, the dolomite refractories go mostly into the stainless industry. And therefore, having a plant in China is obviously strategically a good idea, because about 55% of the global stainless production is located in China with a strong growing tendency. So this is good for us. However, in non-basic, we are basically not vertically integrated, despite consuming all the non-basic raw materials that you see in the slide. We have only one small, comparably small fire clay deposit in Brazil, and that's also more like a legacy mine and not strategic initiative that RHI Magnesita has done recently. So far, this thing is doing very well, and it's a good asset. But from at least our strategic point of view, we would not explicitly go for a fire clay mine because it doesn't make strategic sense. All the other ones we fully procure on the international market like anybody else. So there is basically no benefit in kind of no cost benefit or no strategic benefit in having those raw materials in your own mine. Okay, so let me briefly summarize what we talked about. So the refractory raw material market is a very niche market within the very large industrial mineral market, and it's pretty much dominated by physical trading and dominated by China, as a lot of commodities are. There's, just for the experts here, there's no future, there is no hedging. It is really physical transactions in bulk between parties, sometimes with a long-term index contract or something like this. So there is, of course, spot business, but a lot is still transacted on a more long-term basis. So refractories and refractory raw materials are key for any metal production and for a lot of other industrial processes that we completely take for granted. At least I did it. And so when we split the refractory raw material market, then we talk about the basic raw materials and the non-basic raw materials. And the non-basic are by far bigger, but the fire clay part basically makes it kind of uninteresting for large refractory producers because of the quality of the product. So China, because of its dominance in the market, is very important for the pricing dynamics. And therefore, you have to watch China when you want to understand prices, and you should not watch supply and demand because that's only a very small driver. There is a benefit in vertical integration for refractory producers, but this is basically focused around basic raw materials, particularly magnesite-based raw materials. And therefore, hardly anybody is vertically integrated in non-basic. Maybe the last example I give here, Vesuvius, is our biggest competitor. It has about 2 billion euros of revenue, and they are the strongest refractory producer in the non-basic part. And they, from at least my knowledge, they don't have a single mine. They procure everything on the international market, and they seem to be very successful with it, even making a good margin. But we, as RHI Magnesita, benefit from being vertically integrated because it gives you an extra margin on top of our normal business. And therefore, we continue to do it, and we even expand our vertical integration in certain areas. Okay, I think I'm pretty much on time. Now we can start the Q&A. I hope that most of you are still listening. So please
Yes.
free to add me on LinkedIn. And now maybe, Jean, you moderate the Q&A.
Yeah, exactly. Thanks a lot, Alex. I think it was a great presentation, extremely clear, and yeah, I honestly learned a lot. So thanks a lot. So yeah, as you mentioned, I'm now open to people to ask these questions. So yeah, if you have any question, either you can put them in the chat, or you can unmute yourself or ask me to unmute. I don't know what needs to be done, and then you can ask your question directly to Alex. So we have 5-10 minutes of Q&A time. And so maybe I'll start with my own question, Alex. You mentioned that China is the largest refractories producer. I mean, are they using mostly like their own resources, their own raw material resources, or are they importing? Or I mean, do you see like dynamics changing as well with them importing more and more raw materials? What's the dynamics here?
So the dynamics is that they are fully self-sufficient. They produce basically anything they need. Maybe special graphite is one of the exceptions, but I'm not 100% sure. You also have to mind that the refractory industry in China is a bit less developed when you compare it to Europe and North America. That means the range of high quality non-basic products they consume should be less than in other markets. That means they use comparably little zirconium or chromite or olivine, while these are for some special grades. We, for example, produce very common raw materials. The trend actually is that China even exports more of refractory raw materials than before. And this is because the demand in China shrinks, because the steel production is forecast and expected generally to decline in the next years. And also the cement production, which is a key consumer for refractories, will be lower quite sharply because of very aggressive policies of the Chinese government to cut cement output because of the pollution, and actually nobody needs that. And therefore we face, so the refractory raw material producer that normally sell to the refractory guys within China face increasing pressure to sell to anybody, right? And if the Chinese market doesn't consume it, then they export it, or they try to export it. And therefore prices should be lower in the future, or will at least stay low in the future. But with the big if, the Chinese government doesn't crack down and eliminate this overcapacity, which could happen actually anytime. I hope this answers your question.
I have a question, two questions. The first one is, how have you been affected due COVID? And as far as I know, most of the dead burnt magnesia comes from China. Are there also some games like in other commodities on import and export duties?
Yes. Okay, so let's start with the second question. From my knowledge, there is very little trade barriers against refractory raw materials. However, there are quite a lot of duties in certain countries on the refractory products, most noticeably, for example, in India. And therefore, for example, Chinese material in India, so shipped from China to India, is much less competitive. For the specialty raw materials in the non-basic space, I would doubt that they have any tariffs because there is no market to protect, right, in most countries. So to go to the first question, so demand for our products was heavily hit by COVID in 2020. However, RHIM managed to keep our margins actually quite well, and we had a very successful 2020 actually. However, now we face problems that a lot of other commodity and metal and other guys in the whole actually global economy face. We have issues to supply all the demand that we see currently in the market because of restocking and very strong recovery of everything. And we are basically maxed out, similar to the steel industry actually.
Okay.
And for us, currently is also a difficult. 2020 was also a difficult time because of restrictions in logistics. I told you before that RHI Magnesia has a lot of different production hubs and research and sales offices. So we rely on a functioning global supply chain. And this broke down in 2020. And currently it also breaks down because of very high prices for shipping, container, for example, and also very low availability. So we have currently some issues, but I think we share these issues with a lot of other sectors and a lot of other companies.
All right. Thanks, Alex. Let me check. I don't see any more questions. So I think I'll close the webinar now. So again, Alex, thank you very much. I think great presentation, and yeah, thanks for your time. Also want to thank everyone who joined the meeting today. I think that's great that we have a good participants. Also want to thank, you did it for me, but thank you to Tristan, who is one of our community member and which introduced us to Alex. So I mean, anyone in the crowd, if you have any ideas of webinars, feel free to get in touch. We're more open to open the platform to any young mining professional or even less young. It's not a big deal, but yeah, we're very open to organize things. So please get in touch. Thanks, Alex. Thanks everyone, and we keep in touch.